Today, we're going to add wind and gravity to our particle system. Let's go. So this is the 7th video in our series on making a particle system using the Unreal Material Editor or Unity's shader graph. If you haven't seen the other videos yet, I'll link the playlist down in the description so you can catch up. Last week, we added speed and direction to our particles, and today we're going to add wind and gravity so that the particles can respond to the forces in the world. So to give you an idea of where we are in the process, I've created these 4 sample particle effects using our shader. This one over here on the left is eventually going to be a waterfall. The second one here is going to be chimney smoke. This third one is going to be a fountain. And this fourth one here is going to be drifting mist. So you can see that we've got our particles behaving sort of like what we need, but there are some features missing, and adding wind and gravity today is going to help these out a lot. So let's get started. So we're going to add wind and gravity, and then we'll come back and add these effects to these individual particle systems so you can see what a difference it makes to have these forces. All right, so this is the shader that we've been creating. And last week we added this middle section here on direction and speed. So let's rearrange things just a little bit to give ourselves some room so that we can add in the forces of wind and gravity. I'm just going to move our random values down here just a little bit and our position and offset down just a little bit. And we're going to put the nodes that we need for wind and gravity right here in the middle. All right, so the first thing that we need to do is create our 2 parameters. So I'm going to hold down the 4 key and click. And there's our first one. And I can just right click on it and pick convert to parameter. And we're going to call this one wind. And we're going to leave the default values at 0, 0, 0. And I'm going to come down here to the group and I'm going to put it in the forces group and give it a priority of 13. And now we're going to make another one, and this one's for gravity. So I'll right click and pick convert to parameter and name it gravity. And this one we're going to give a default value of negative 500 in the Z. So the Z is the up parameter, and negative means it's down, so gravity is defaulting to negative 5 meters per second. Now, normally gravity is negative 9.8 meters per second, but by default, we want our particles to feel just a little bit lighter. And so I'm using a value of negative 500 here. Now, these values are in centimeters, that's why they're 500 instead of just 5. So this is going to give us negative 5 meters per second. And we're going to come down here to our group, and again, we're going to put it in the forces group. And we're going to give it a priority of 12. All right, the next thing that we need to do is take these 2 parameters, our wind and our gravity. Oh, and by the way, the values that we give for wind and for gravity represent both the direction and the strength. So like in the case of gravity, the direction is negative Z, but the strength is 500. So we have both the strength and the direction built into these values. Okay, so now I can take these 2 values and just simply add them together to accumulate the forces of both wind and gravity. And now I need to add in my object's position. And this is the position of the stack of particles. So there's my object position node. So I'll add in my object position. And now we need to convert our forces from world space to local space, because all of the other calculations that we're doing here are in local space. And so I need to add a transform node here. So there's my transform, and by default, transform goes from tangent space to world space, but that's not what I want. I want mine to go from world to local. And so what's happening here is these gravity values that I have are in world space. So my wind is blowing in world space, my gravity is pushing in world space, but then I convert it to local space here so that I can combine it with the other world forces that we have. All right, and my last step is to combine... Oh, one more thing. I need to multiply this by my lifetime. So I'm going to add a multiply node here. And I'm going to come over here to this frac node here. This is my particle lifetime, as I've indicated with this little label here. And I'm going to bring down my particle lifetime and multiply it by my forces. And what this does is, the longer the particle is alive, the stronger the effects of wind and gravity are on that particle. So when it's first born, it doesn't move very much according to wind and gravity, but those values accumulate as its life gets longer and longer. And so we're multiplying by the particle's lifetime. So the longer it lives, the more it'll be pushed and pulled by wind and gravity. All right, and then the last thing that we need to do is add in our forces of wind and gravity here to our velocity and direction. So I'm going to create an add node and wire in our wind and gravity and combine it just like that. All right, and then our shader is going to recompile. And as soon as it does, now you can see that our particles are being pulled down by the gravity. That's pretty cool. It's great to see an effect that we've been working on working correctly. So now what I can do is I'll save my shader and we can switch back to our scene, and I'm going to go ahead and add gravity and wind values to each of those 4 experimental particle systems that we created, so that we can see how adding these new parameters helps us to better achieve the effects that we're going for. Before I do that, I'm just going to group these values here. So I'm going to select the nodes that we just created and pick create comment from selection, and I'll call this wind and gravity. We like to keep things nice and grouped so that it's really easy to see where the various parts of the shader are and where we need to make changes if we want to remove things or add things or modify the way that things are working. If we keep things grouped and nicely organized like this, it's really easy to see what's what and where to make changes. All right, so here we are in our experimental scene, and things don't look quite right. You can see that all of our particles are kind of moving off diagonally like this, and I think I may have made a mistake. So I'm going to switch back to our particle system and take a look really quick. So here we are, and if we kind of zoom in on the nodes that we've been working on, you can see that I've used a transform vector node here, and what we're dealing with wind and gravity are positions, and so I need to use a transform position node instead. So I'm going to grab the transform position node, and we're going to set it to absolute world space to local space. Then we're going to replace the transform vector node with the transform position node. That should get us what we want a little bit better. All right, let's save this shader and come back and take a look and see what results we're getting now. Okay, this looks a little bit more realistic. You can kind of see our particles are moving down in response to gravity now. So let's go ahead and open up some of our material instances and see what we can do by playing around with our material parameters. First, let's take a look at our waterfall here. So this is our material instance that controls the waterfall. And you can see that I've added the forces category here. Now I have gravity and wind. Wind is just defaulting to 0, but gravity is defaulting to negative 500 here, 500 centimeters. So I'm going to check on gravity. And, obviously if we set this to 0, our particles are not going to be pulled down by the force of gravity. But if we set it to, let's set it to positive 800, now they're being pulled upward. So that's kind of interesting. Maybe negative 700. And now what you can see is our particles are really starting to look more like a waterfall. Before we had wind and gravity, they just kind of blobbed around like this. But now that we can actually pull them down with the force of gravity, we're getting something that is behaving more like a waterfall. And that's pretty cool. All right, our next particle system is our smoke. You can see our smoke particles right here. And if we go down under our ground plane here, you can see they're just getting pulled directly down by gravity, which is not really what we want. And so let's go ahead and bring in their material instance. So here's the material instance for our smoke particles. Our gravity is pulling them down right now, and we actually don't want that. We want them to be kind of rising into the air. In fact, we might want to just give them some slight negative gravity so they're moving upward instead of downward. There we go. And now the interesting thing that we want to add with the smoke particles is a little bit of wind. So we want to make sure that, or we want to make it seem like the smoke is getting blown in the wind. And so I'm going to open up our wind parameter here. We're going to turn that on. And maybe we can give our smoke just a little bit of influence from the wind, so that as the smoke particles get emitted, if this is our fire or our smokestack down here, as the particles get emitted, they get caught by the breeze and pushed off to the side there. Maybe we can give it a value of 300. That might be a little bit strong, but what you can see here is that our wind value is able to influence our particles and push them away. And so we've successfully added these wind and gravity parameters so that we can apply external world forces to our particles. And that's pretty cool. All right, this one here, this third one is our fountain. So let's go ahead and bring its material instance in. Here's our fountain material instance. And this one is already working pretty well with this default of negative 500. If I set this to 0, this is what we had before, where our water, so with this fountain, we're having water that's getting sprayed up in the air. And what we want it to do is get caught by gravity so that the particles get emitted and then get pulled back down. But without gravity, they're just going straight up. So if I add gravity here, you can see that the particles get emitted at the bottom, and then they get pushed up and then pulled back down. If we play with this gravity a little bit, we can get various results. I think this one's gonna, well, all of these are gonna look a lot better once we get the texture applied to them. But we're gonna do that a little bit later on in a couple more videos. Maybe we can just leave this for now at negative 300, or negative 300 rather. So you can see the particles getting created and then getting pulled back down with the gravity. All right, and then this last one here, this is our mist. And it was already looking pretty good, I think, because mist just kind of subtly floats around. And what we've done now is we've added gravity to our mist, and so it's getting pulled down, which is not something that mist really does. So let's bring in our material instance here for the mist, and we'll just turn off that gravity so that our mist, instead of getting pulled down, it's just kind of randomly floating around. All right, so if we take a look at our 3 particle effects now, or our 4 particle effects, you can see that they're behaving significantly more like the natural phenomena that we're trying to imitate. We have our waterfall here, that's the water kind of cascading down. We have our smoke being blown by the wind, and we have our fountain that's emitting water straight up, and then the particles are getting pulled back down. So adding these forces values today really helped to add the features that we needed to make these particles more like what we're trying to imitate. All right, next week we're going to add rotation to our particles. Right now you can see that all of the particles are just kind of fixed in their alignment with the screen. They're all lined up horizontally and vertically with the screen. But next week I'm going to show you how to add parameters in to control whether they're rotating clockwise or counterclockwise, how fast they're rotating, and if they want to just be statically rotated or if they want to animate their rotation. So we're going to be doing that next week. But before we do that, let's switch over to Unity and I'll show you how to add the same gravity and wind forces there. All right, here we are in Unity. And just like we did in Unreal, we've got our 4 sample particle effects set up here. Over here on the left, we have our waterfall. And then here we have what's going to be our smoke eventually. And here is our fountain and our mist particles. And what these are missing right now is they don't have the ability to, take on the forces of gravity and wind. So we're going to be adding gravity to these and wind. For the waterfall, gravity is going to help because it's going to pull the particles down. For the smoke here, for the chimney smoke, the wind is going to be able to pull these so they're kind of affected by the breeze. And especially for this fountain here, where our particles are just going straight up in the air, we're going to be able to emit these in the up direction, but then the gravity is going to pull them back down. So let's go ahead and open our shader, and we can add wind and gravity to these to our particle shader. So here's the shader that we've created so far. And just like we did in Unreal, I'm going to move these down just a little bit to give us some more room to add in our forces. Maybe I'll grab these up here and just move them upward, just to give us a little bit of room. All right, the first thing that we need to do is add 2 vector3 parameters. And we're going to call the first one wind, and we're going to call the second one gravity. And for wind, I think we'll just default it to 0, 0, 0. As you can see here, it's already set. And for gravity, we're going to give it a value of -1, which means it's getting pulled down. Y is the up vector, so -y means it's getting pulled down. And we're pulling it down by 1 meter per second. Normally, gravity is -9.8 meters per second, but that's on like solid objects. And what we're simulating here is little particulates in the air and that sort of thing, and they don't get affected quite as much by gravity. Of course, this is something that you can adjust to get the behaviors that you want. But for now, we're going to leave the default at -1. All right, so then I'm just going to drag my wind parameter and my gravity parameter into the scene. And I'm going to create an add node, and we're going to add both of these values together. So wind represents both a direction and a strength, as does gravity. And so if I give this, the higher the number, the stronger the gravity is pulling down. And I can add these 2 values together to get kind of a cumulative total of the forces of wind and gravity together. All right, the next thing that I need to do, once I've got those added together, is I need to add in the position of our original object. So I'm just going to type object and bring in our object here. And there's a bunch of parameters that we can grab from the object, position, scale, bounds, etc. But I'm just going to be using the object's position. We're going to add that to the forces of gravity. And now, so these forces are currently in world space, and we need to transform them from world space into object space, which is the space that the rest of the particle behavior is happening in. So I'm just going to drag out here and add a transform node. And like I said, we're going to set this to world because that's where we're starting out. And then we're going to transform to object space. and we have a position. So everything's set up correctly here. So we're taking our forces, which are world forces of wind and gravity, and converting them to object space so that they can then be combined with the rest of the forces in our particle system. And finally, to just finish off our wind and gravity section here, I'm going to add a multiply node. And with this multiply, I'm going to grab our value here that represents our particle lifetime. In fact, I'm going to add a sticky note here really quick, just to remind myself that this value represents our particle lifetime. So I'm going to grab our fraction value here and multiply it by our forces of wind and gravity. And then what this does is, when the particle is first emitted, it's not influenced by gravity and wind very much. But the longer the particle lives, the more of that wind and gravity influence starts to assert itself. So when it first comes out of the emitter, it's going to be right at the position of the emitter. But the longer it lives, the more it's going to be pushed away from its original location and pulled down by gravity and pushed by wind. So that's why we multiply our wind and gravity forces here by the lifetime, because the longer the particle lives, the more effect the wind and gravity has on it. Okay, and then the last thing that we need to do is to just go ahead and combine our wind and gravity forces here with what we're already doing. This is the part that we created last week, the direction and speed. And so this represents the direction the particles are moving. And then this represents this, the speed they're moving in. And we combine those values together. And now we can just add in our forces of wind and gravity here. So this is what we did today. This is what we did last week. And we just combine them together with an add node. So now we've added in our forces of wind and gravity with our direction and speed parameters. All right, I'm also going to take these parameters here in our blackboard and add a category. And we're just going to name this category forces. And I'm going to grab our forces group and drag it down here below our movement group, just to keep things kind of organized in the layout of our parameters. Okay, so that's all we needed to do. Oh, I guess I'll do one last thing. I'll select these and pick group selection, and we can call this group wind and gravity, just to kind of keep things nice and organized. There we go. Okay, let's switch over to our scene and see how adding wind and gravity can improve the appearance of the sample particle effects that we've created so far. Okay, so here we are in our scene. You can see we've got our 4 example particle effects going. And I've also opened up the properties of the materials of each of the 4 effects up here at the top, so we can play around with their values and see how the values that we added today will affect the behavior of the particles. So let's first work on our fountain over here. Before today, we had 0 wind and 0 gravity, so our fountain was looking something like this, this is the waterfall. Not very effective looking as a waterfall, but let's add gravity to it. So we're going to add negative y gravity. So I'm just going to add negative 9.8, which is the speed of gravity in real life. So now that we've added our gravity in, you can see that our particles are getting pulled down by gravity, and this looks significantly more like a waterfall than it did before. So that's working really well. So we got negative 9.8 for our gravity there. Okay, here are our smoke particles. And what we need to add here is some wind. So you can see by default, I'm giving it wind of 1. This is the way that it looked before, with the particles just kind of rising straight up into the air. But if we do give them a little bit of wind amount, you can see that when they're spawned and then they get caught by the breeze and pulled off in the direction and speed of the wind that I'm giving them. So let's maybe give them a wind of a value of 2 meters per second. And you can see now that the smoke is getting pushed along by the breeze after coming out of the fire or the smokestack or whatever it is that's creating this wind. Okay, over here we've got our fountain. And you can see that we've given it a little bit of gravity, and that's working really well. Originally, our fountain particles were just going straight up in the air. But now that we can add gravity, we can spray them up, but then pull them down with the gravity here. So if I give it a value of -6 here, or maybe a -4, you can see now it's looking more like a fountain because the particles are getting sprayed out, going upward, and then that upward momentum is getting overcome by gravity here, and they're getting pulled back down. Now for our mist particles, I don't think we really need to change much here because they're just supposed to look kind of floaty. And so what we've done is we've added a value of positive gravity of 0.4. So this is pulling our mist up in the positive y direction just a little bit. But mostly we want our mist particles to just kind of float and have a little bit of random movement on them. All right, so what you can see now is that with gravity and wind, we've been able to get our example particle effects to look a lot more like the natural phenomenon that we're trying to imitate. So we've added gravity to our waterfall, we added wind to our smoke, we added some gravity to our fountain, and some positive gravity to our mist. All right, so we made some good progress today. Like I said when we were in the Unreal section, next week we're going to be adding rotation to our particles. So right now all the particles are perfectly aligned in the horizontal and vertical direction with the screen, but we're going to be rotating them around the camera axis so that we can give a little bit of variety to the way the particles look. So they're a little bit, rotated. And we're going to add some controls to rotate them clockwise or counterclockwise, how much rotation, how fast to rotate them, all those good things. So be sure to come back next week and continue in our journey of creating this particle system in Unreal's Material Editor and Unity's Shader Graph. Hey, thanks for watching, everybody, and we'll see you next week.